Let's take a look at how we can combine the ideal gas law with what we know about stoichiometry to solve a real-world problem. So, if you burn an unknown amount of propane, using the balance equation given, and produce 1.35 liters of CO2 gas, the pressure is 1.02 atmospheres and the temperature is 23 degrees Celsius. How many moles of propane did you burn? Now, it's important to identify what's going on in this. You're told it's a gas, so you know that you're going to be working with the gas laws. You're looking at a specific moment in time because you're only looking at one volume of gas, one pressure of gas, one temperature of gas. There's no change happening. So that tells you that you're going to be working with the ideal gas law. So PV equals nRT. Now, the ideal gas law, notice it's got N in it, moles. So just like before where we used molar mass to go from grams to moles, we can use the gas law to go from all of the different measurements of the variables of a gas to the number of moles of a gas. Because we have a volume, so we have volume right here. We have a pressure right here. We have a temperature right here. And R is a constant. So we have everything we need in this equation to be able to find the moles of gas. Now, it's important to keep in mind that this gas is moles of CO2. So that N will give us the moles of CO2. Okay. So we're going to have all of the, so we're going to start with our liters of gas. We're going to use the gas laws to convert, and all of the other variables, to convert to moles of CO2. So liters particularly of CO2. We're going to convert to moles of CO2. Then, this is just a stoichiometry problem like we've done before. We can convert from moles of CO2 to moles of C3H8, or propane, using the balanced equation. So we're going to go through those steps. So first we need to find the moles of CO2 produced. To do that, we're going to have to use our PV equals nRT. We want to rearrange this equation to solve for moles. So PV equals nRT. I want moles by itself, so we're going to divide both sides by RT. You can divide both sides by R and then divide both sides by T, or you can do them both at the same time. So I'm going to divide both sides by RT. It's going to cancel out RT on this side. So now I have my moles is equal to PV over RT. Okay. Next, I'm going to have to substitute in the values from the problem. So if I look back at my problem, I have 1.35 liters, I have 1.02 atmospheres, and I have 23 degrees Celsius. Now, I need to be careful about all of my units. So my temperature is going to need to be in Kelvin. Right? So I have my pressure from the problem is 1.02 atmospheres. My volume, 1.35 liters. And my temperature is 23 degrees Celsius. I need to convert that to Kelvin, so always make sure and convert to the appropriate units. I'm going to add 273. I'm going to get 296 Kelvin. Okay. So why did I know I needed Kelvin and why did I know liters and atmospheres were okay? Because I'm going back and using that R value of 0.0821 liter atmosphere per mole Kelvin. So your volume is going to have to be in liters. It's already in liters, so that's great because we don't have to do that conversion, but you might have to on some problems. My pressure is in atmospheres, so that's good. Moles is what we're looking for, so that's good that we have moles in there. And our temperature now, we've got it in Kelvin. So now I can actually just plug my R, my P, my V, and my T into this equation. Okay. So I plug my values in, multiply through, I get 0.0567 moles of CO2. So do make sure, one common problem folks have when they do these types of problems is not putting it into the calculator correctly. So sometimes, you may want to make sure and put parentheses when you plug it into your calculator so your calculator knows you're taking all of this and dividing by all of this. Notice also that my units cancel out here. Kelvin, Kelvin, atmospheres, atmospheres, liters, liters. The only unit I have left is moles. That's what I want. So this is set up correctly. Now, that's the moles of CO2, because that's the gas we're looking at. We still need to find the moles of C3H8. So we're going to use the moles of CO2 and the balanced equation to find our moles of C3H8. So from the previous, we know it's 0.0567 moles of CO2. If we look at the balanced equation, there's 3 moles of CO2 for every 1 mole of C3H8. So I can set up my conversion using my balanced equation, 1 mole C3H8 for every 3 moles CO2, and I get that I have 0.0189 moles of C3H8 for my final answer. The key with these problems is to be very careful about labeling everything, label your units, keep track of everything. No particular step is super complicated, but it's a lot of little steps and a lot of things to keep track of. So label meticulously.